The following module discusses another type of life tables in the study of mortality called the multiple decrement life tables. Various terms used in discussing the multiple decrement life tables are discussed, including terms such as cohort, attrition factor, life experience, measured by duration of use, etc., and the steps involved in the construction of the multiple decrement life table and the difference between the ordinary life table and the multiple decrement life table. The difference between an ordinary life table and a multiple decrement life table is also discussed, wherein the main difference is that in multiple decrement life tables, there are multiple reasons for attrition or termination of life, while in the single decrement life table, there is only one single attrition factor under consideration amongst other reasons. Steps involved in the construction of the multiple decrement life tables are discussed along with giving examples of how these tables have been used in these studies.
I am Dr. C.P. Prakasam, retired professor from International Institute for Population Sciences, Mumbai. I will be discussing multiple decrement life table, module 28, learning objectives, definition of multiple decrement life table, terms used in multiple decrement life table, steps involved in construction of multiple decrement life table, difference between an ordinary life table and multiple decrement life table. Definition: single decrement life tables pertaining to the life experience of a cohort with single attrition, namely death or marriage or getting employment, etc., to a single problem. Module 26-27 will explain. A multiple decrement life table summarizes the life experience of a cohort in which population exposed to several causes can be terminated by two or more attrition factors. Multiple decrement life table: life experience of a cohort, termination due to attrition factor 1, attrition factor 2, attrition factor 3. Description of terms used in multiple decrement life table. A cohort is a group of individuals to whom a certain event occurred at the same period of time. Example: a birth cohort is a group of people born at the same time or in the same time interval. A marriage cohort is a group of people married at the same time or in the same time interval. A cohort of contraceptive users is a group of individuals who began using contraceptives at the same time or at the same time interval. Number 2. Attrition factors. Attrition factors are events experienced by individuals of a cohort that makes them no longer eligible to member of the cohort. Example: members of a birth cohort lose their membership in a cohort by death due to different causes. In this case, the attrition factors are causes of death. Members of marriage cohort lose their membership in the cohort by marital disruption, either by separation, divorce, or death of a spouse, widow. Attrition factor. Example: members of a cohort contraceptive lose their membership in the cohort by stopping use of the method for various reasons, for example, accidental pregnancy, plan to conceive, medical reasons, last follow-up, or method failure. Number 3. Life experience. In a multiple decrement life table, the life experience is measured by the time spent by an individual as a member of the cohort. If an individual leaves a birth cohort by death, the life experience of individual is equal to the length of life. If an individual leaves a marriage cohort by the termination of marriage, then the life experience is measured by the duration of marriage at the time of termination. If an individual leaves a cohort of contraceptives by terminating the use of contraceptive, the life experience is measured by the duration of use. Difference between an ordinary life table and multiple decrement life table. In an ordinary life table, membership is well-defined cohort can be terminated by a single attrition factor. In a multiple decrement life table, there are multiple reasons for attrition. Difference between the ordinary life table and multiple decrement life table. The ordinary life tables can be used to answer questions about longevity, namely, what is the probability that a newborn will survive to age 65, or what is the probability that a newborn will die before reaching age 65. A multiple decrement life table will be used to answer the question, namely, what is the probability that a newborn will die due to a specific cause before reaching age 65. In an ordinary life table of mortality, it is assumed that everyone eventually die. In multiple decrement life table, will provide the probability that a person will eventually die due to specific cause. Steps involved in construction of multiple decrement life table. Step 1. Initially, construct an ordinary life table with the data on a specific death rate. Step 2. Distribute the death in each age interval in the life table to various causes using age cause specific death ratio. Step 3. Calculate the cause specific death probability. Step 4. Cumulative deaths by cause in the life table to compute eventual probabilities of death by cause. Multiple decrement life table example. To illustrate the multiple decrement life tables, we will choose deaths due to diarrhea, cancer, cardiovascular diseases and other causes. Mortality due to these 4 causes are used to construct multiple decrement life table example. Data required for constructing causes of death multiple decrement life table. Age specific and age cause specific death rates. This data could be in the form of age specific death rates and age cause specific death ratios. Due to diarrhea, cancer, cardiovascular disease and other causes. Construction of multiple decrement life table. Step 1. Initially, construct an ordinary life table with the data on age specific death rates. See module 28. Step 2. Distribute the deaths in each age interval in the life table to various causes using age cause specific death ratios. Step 2. Age specific death ratios. For illustration purpose, we will select Costa Rica male life table. Number of deaths in the age interval 0 to 1, 1D0 is 7230, it is given. The cause specific death ratios expressed here as proportions for 0 to 1 age group as table 1, diarrhea 0.2408, that is multiplied by the cause specific death ratio 7230 multiplied by 0.2408 equals to 1740. Similarly, if you look at that cancer, cardiovascular diseases and other causes have been computed. Step 2. Distribution of deaths to various causes using age cause specific death ratios. In an ordinary life table, the total number of deaths in a specific age interval is given by the NDX values. Denote the cause specific death ratio for a specific cause RD in the age group interval X plus N as NCXD. Then number of deaths due to a specific cause RD denoted as NDXD in the age interval X plus N is calculated as NDXD equals to NDX multiplied by NCXD. Total deaths multiplied by cause specific death ratio. See table number 2. Step 3 and 4. Step 3. Calculate the cause specific death probabilities. Step 4. Cumulate deaths by cause in the life table to compute eventual probabilities of death by cause. Step 3. Computation of cause specific death probabilities. Use the information from step 2 to compute cause specific death probabilities. In an ordinary life table, the proportion dying in a specific age interval x plus n or nqx may be interpreted as the probability that a person of age x will die in that age interval. This quantity is computed as nqx equals to ndx by small lx. Similarly, in the multiple decrement life table, the proportion of individuals dying in the specific age interval due to a specific cause Rd is considered to be the probability that a person of age x will die in that age interval x plus n due to the cause Rd in the presence of all other causes, denoted by nqxd. nqxd is the probability that a person of age x will die in the age interval x plus n due to a specific cause where all other competing causes are present in the population. Because the probability nqxd is computed as death probability under the assumption of presence of all other possible causes of death, it is often termed as the crude probability of death due to a specific cause. This probability is computed from the life table deaths due to a specific cause as nqxd equals to ndxd divided by small lx. Step 3. Cause specific death probabilities. Collecting data from table 2, row 1, less than 1 year as L0 equals to 100,000 radix, 1 D0 equals to 7230, 1 D0 of the diarrhea equals to 1740, 1 D0 cancer equals to 6, 1 D0 CVD equals to 55, 1 D0 other, that is other causes, equals to 5428. Cause specific death probabilities for the age less than 1 year. Diarrhea equals to 1740 divided by 100,000 equals to 0.01740. Cancer equals to 6 divided by 100,000 equals to 0.00006. CVD equals to 55 divided by 100,000 equals to 0.0055. Other causes 5428 divided by 100,000 equals to 0.05428. For other age groups by cause up to 85 is given in table number 3. Step 4. Computation of cumulative number and eventual probabilities of cause specific deaths. Compute the number of persons dying due to the specific cause after specific age. For example, due to diarrhea, the number of deaths after age 65 due to diarrhea is the 5D65 diarrhea plus 5D70 diarrhea plus 5D75 diarrhea plus 5D80 diarrhea plus D85 plus diarrhea, that is 129 plus 246 plus 177 plus 406 plus 461. Data from table number 2 equals to 1430 with rounding. Similarly, for all other causes and other age groups, cumulative number is calculated and given in table number 4. Similar sums give the cumulative number of deaths after age 65 due to cancer, CVD and other causes. These sums are shown in table number 4. Step 4. Eventual death probabilities. Table 5 shows how many persons die due to specific disease after a specific age. From this table, we can calculate the eventual death probabilities by cause for a newborn baby, that is, eventual death probability at age 0, and extend this concept to other ages. We can derive what is the probability that a person survive to age X will eventually die due to a specific cause RD. Denote this as probability as PD. Eventual death probability at age X by cause RD, PD equals to LXD divided by LX. Example, data from table number 5. L65 equals to 63,605. L65 diarrhea equals to 1420. L65 cancer equals to 10643. L65 CVD equals to 22212. Therefore, P65 diarrhea equals to 1420 divided by 63605 equals to 0.02233. Similarly, other causes also given here. Eventual death probability at age 65 due to diarrhea is 0.02233. Cancer is 0.16733, CVD is 0.34922, and other causes is 0.46113. Eventual death probability at different ages is given in table number 6. Example of application. A study creates cohort life table by birth cohort and age to remove breast cancer as a cause of death by determining mortality from causes other than breast cancer. In this study, an all-cause cohort life table is divided into mortality due to breast cancer and mortality due to causes other than breast cancer. The time period considered is here a birth 1900s to 2000. The data facilitates analysis of effects of screening and treatment intervention on mortality due to breast cancer. Here I would like to ask some questions. From the module, you can answer all the questions independently. Questions. 1. Describe the difference between an ordinary life table and multiple life table, decrement life table. 2. Describe the attrition factor in multiple decrement life table with examples. 3. Describe the 4 steps involved in construction of multiple decrement life table construction. Fill in the blanks. Following is the filling the blanks. You can fill it up by using the module information given in this. Thank you very much.
Right, and to a large extent there could be possibilities now in real world that there are multiple decrements, especially a policy could be either surrendered or there could be a death benefit that could be paid on it. So two different statuses could be there. So the number of policies are coming down either because of surrender or because of death, or probably it might be some kind of withdrawals. So there could be different statuses that could be associated to policies, and the number of policies could come down because of many scenarios which need not be associated with the final. It need not be one element that is influencing the decrement in the numbers. There could be more than one force that is acting at a point in time. Right? As I said, the population can go down, the number of policies, enforced policies can go down, one because of death, one because of the maturity of the policy, and one because of the surrendering of the policy. These are all multiple decrements, right? So there could be even if I am looking at a whole life policy, there could be a death, there could be a surrender. So in some kind of policies, there are multiple such kind of decrements. For a few of them, there could be 2 or 3 kind of decrements that are there. So wherever we are talking about the multiple decrements kind of a scenario, if I am talking about LX being the regular population whose age is X, that is available at a particular point, here we are defining ALX. ALX is talking about the population, again, whose age is X, based on some kind of a definition. And here, let's say I am talking about 2-3 decrements, alpha, beta. Alpha could be death, beta could be surrender. So different kinds of independent decrements to which the population is really subjected to. Now what we are simply saying is, we are building a multiple decrement table. The same way we had a life table for one single decrement, which was the death. When there is a multiple decrement, we are building a multiple decrement kind of a table, which is simply saying AL of X plus 1 means the number of lives of age X plus 1 that are alive is nothing but out of the lives whose age are X that are alive, I'll remove the lives, the number of deaths or number of population, number of lives that have exited because of alpha, because of the decrement alpha, minus the number of lives that have exited the population because of the decrement beta, because of the decrement gamma, because of the decrement delta, and anything like that. So the number of population that got decremented or number of lives that got exited out of the population of enforced policies, either because of any of these decrements, is resulting in the computation of AL X plus 1. And in a large number of cases, we see that all these decrements, they are operating independently. So if one is occurring, I can't expect the other one to occur. So they are occurring almost independently.